Hello, my cool buddies. Today we will read or study the concept of graph. What is the graph? Graph is a second version of the tree where present some, as usual, present some uh, nodes and some edges. Okay, where two nodes are connected via edge. Okay, this is called a graph where some nodes and edges are present, which is called a graph. This is the simple concept of the graph. Then, is this a graph? This is a tree, we all know. Is this is a graph? The answer is yes, because here the node is present and the edge is also present. We can tell that this is a graph. Means every tree is a graph, but every graph is not a tree. Like this is a graph, you can say, because there is also nodes are present, so also edges are present. So this is also a graph. Can we say that this is a tree? No, because if there is a node, this is a root node according to tree, and it there is a two child node for the tree, and this is a tree definition, because there is a root tree, and for the root tree there is maximum two child nodes are present. So there can be multiple nodes can be present for a one node. Okay, so this is not a tree at all. Now how can we store a tree? Now I at first I draw a tree. This is a one, this is a two, node 2, this is node 3, this is a node 4, this is a node 5. Now at first I want to clear about the edges. Okay, now this is called the undirected edges. Means when there is no arrow in the edges, means the arrow is present at the both side. Means we can go 2 to 3, we can go 3 to 2. Both directions are open. We can reach 3 via 2, and we can reach via 2 via from 3. So this is called undirected edge. But what is the direct mean? When a edge is present, when an arrow is present there, here I just draw. When an arrow is present, means there is an arrow present, means we can reach 5 from a 4, but we can reach a 4 from a 5. This is not allowed. When an arrow is present, this indicates the direction. This is the simple concept of a graph. Now how to store a graph? We can store a graph in two ways. One is adjacency list, second is adjacency matrix. Okay, in these two ways I can store a graph. And how can I store? In the left side I just remove all these things. In the left side I just draw a tree or graph. This is 1, this is 2, this is 3, this is 2, this is 4. Okay, let that this is a graph. Now I can tell that from 1 I can reach, from 1 I can reach 3, also I can reach 2. As well as for 3 I can say from 3 I can reach 1, or there is no other node is present. From now just go for a 2. From 2 I can reach 1 and I can reach also 4. Now 4 from I can reach 2. This is called adjacency list, where this is the vector indexes and this is the its adjacent node means its neighbor. Adjacency nodes means neighbor node, which nodes are connected to a node, which that node is called the adjacency node. Now this way we can store a adjacency list. I can give you example about the adjacency list. Now this is your vector, this is your array or vector, you can say. Now this is the index 0, this is index 1, this is index 2, this is index 3, this is index 4. For the one which nodes are present, there is 2 and 3. For 2 there is only 1 and 4. For 3 there is only 1. For 4 there is only. This is called the adjacency list. How can I represent this? I initialize this vector in this way. Vector I will write this again. Vector where int comma int vec, or I can write in the 2D vector ways. Vector I don't write it fully. Int vector. In these two ways I can store a adjacency list. Now what is the adjacency matrix? Okay, what is the adjacency matrix? Now the adjacency matrix is the same thing, but there is little difference between the adjacency matrix and adjacency vector. Now here I draw the I draw the tree again. This is 1, this is 3, this is 2, this is 4. Now what is my adjacency list? I just draw matrix. How many nodes are there? There are 4 nodes. For the this is not depend on the edges. This is totally the adjacency matrix depends totally on the node. Means adjacency matrix size is equal to the number of nodes. This is a n cross n matrix. That means the n number of rows and number of columns are same. There are 4 nodes. Means the 4 cross this matrix will be 4 cross 4. I write here 1 2 3 4. Here I also 1 2 3 4. Now how can I write this? Now there is a edge between 1 and 2, means 1 and 3. Okay, let's repeat this thing. Now check for 1 1. Is there can I reach 1 from a 1? Is this possible? So I write here 1 from 2, and I just the diagonal also I can reach 2 from the 2, so I write here 1. I can reach 3 from the 3, so I write 1. I can reach 4 from 4, so I write here 1. Now can I reach 2 from 1? Yes, I can reach 2 from 1, so I write here 1. Can I reach 3 from 1? Yes, I can reach 3 from 1. But is there any edge between 1 and 4? No, there is no edge between 1 and 4, so I can't reach 4 from 1 directly. I can't reach 4 from 1. Now for 1 and 2, can I reach 1 from 2? Because I can reach here, I can reach 1 from 2, so I write here 1. Can I reach 3 directly from 2? No, I can't reach 3 from 2 directly. For that there will be 0. Can I reach 4 directly from 2? Yes, I can reach. Now this way I fill total matrix. Now for the 3, that I can reach 3. The 1 I don't reach 2 0. I can reach 4, no 0. Now 4 only there is 2. Okay. The left of the cells will be 0. This is called the adjacency matrix. There is in LeetCode question the adjacency list and adjacency matrix both are present. To solve any questions, sometimes adjacency list will be helpful, sometimes adjacency vector will be helpful. Now, how can I iterate graph? To iterate a tree, there are 3 options: pre-order, in-order and post-orders. Now, how can I iterate a graph? For iterating a graph, there are 2 options present. What are these 2 options? One is DFS and second one is BFS. Means one is BFS, breadth first search, second is DFS, means depth first search. Here we search breadth wise first, here I search depth wise first. Means breadth wise means I firstly store the same depth store. Now I just want to give you example of BFS. I just give you example of BFS. There is 1, there is 2, there is 3, there is 4, there is 5, there is 6. Now I need to iterate this. Now I need to iterate this graph. Now how can I iterate? This looks like a tree, but I don't write this. I can add a node between this. Okay, now how can I iterate? I will start from a 1. At first I stored in a vector 1. Now I went to the nodes which are connected to the 1. There is 2 and 3 which are connected to 1. Now I write 2 and 3. There is no other node which are connected to 1. Now I now find which nodes are connected to 2. There is only one node which is connected to 2, which is 6. Now I find for the 3. Which nodes are connected with 3? Connected with 3 is 4 and 5. Now further, which nodes are connected to 6? There is 4, it's already written, so I don't write again. Now there is no other node which is connected to 6 or 4 or 5. So this is the breadth wise search, means I store the all nodes level wise. This is level 1, this is level 2, this is level 3. This is called the breadth first search. Now I just if I calculate the distance from 0 to every node, there is the distance is 0, there is distance 0. Now there is distance 1, 0 plus 1, there is distance also 0 plus 1, 0 plus 1. Now I can see to reach 6 from 1 we need 1 second. If I calculate this as a time, to reach 4 I need 1 second. For reach 5 we also need a 1 second. So these nodes are at same level, these nodes are same level, these nodes are same level. This is called the breadth first search. Now come to our next iteration method, which is called the breadth first search. Now how can I perform the breadth first search? To perform the breadth first search, we go to the depth first. Means if I start from the 1, I will go to 3 first, then I go to 4. Means I go to the depth. Means I write 1, 3, 4. Now I backtrack to 3. Now I backtrack to 3 to 2. Now I can go 3 to 4. So I write 3 to 5. Now write here 5. Now I write, now I backtrack again. Now I can from 1 I can reach 2, 2 to I went to 6, 6 to I can went to 5, 5 is already visited, I don't write 5 again. So this is the sequence. Here I went to the depth first, then I backtrack. This is called the DFS method. So this is all about the graph in short. So thank you.